Today we're going to talk about properties of real numbers, section 1.2. This should be a review from Algebra 1. You would have seen all of these properties in Algebra 1. You would have also seen them in 8th grade, 7th grade. Typically, probably all of your math classes start out with learning these properties. But properties of real numbers, if you look over on the board over here, some of the properties are actually listed up here. They're on the far right side. Those are properties we're going to talk about today. All right, first one we're going to talk about today is the properties of addition. First one is the additive identity property. So the identity property of addition. Additive identity means that you can always add and get the same number. Well, what digit can I always add and will always come up with the same number? 0. Anytime you add 0, you always come out to be the same number. So, for example, 4 plus 0 is 4. 5 plus 0 is 5. 10 plus 0 is 10. Keeps going and going and going and going and going. Okay, that is the identity property of addition. Next is the inverse property of addition, or the additive inverse property. The sum of a number and its opposite is 0. So the additive inverse, they are the opposites. Additive inverse is also considered the opposites. Okay, so 8 plus negative 8 is 0. If I were to say 7, what's the additive inverse going to be? Negative 7. 7 plus negative 7 is 0. Additive inverse. Closure property. Closure property just means that you're going to get a real number. Okay? So closure property, 3 plus 5 equals 8. Okay? It's a real number plus a real number gets me another real number. That is the closure property. Commutative property. Very common. You see this one a lot. Commutative property. The order does not change the sum. 6 plus 12 equals 12 plus 6. I can flip around the way that I add, and it'll get me the same thing. 1 plus 2 is the same thing as 2 plus 1. That is the commutative property. That one was actually listed over here on the board if you look at it. Okay? There's commutative property. Then the other one here is the associative property. Associative property is similar to commutative property. The difference is associative property has groups of numbers. Okay, so if you look here, commutative property is always just 2 numbers flipped. Associative property is typically 3 or more. So I'm changing the order or the grouping in which I add. So I'm going to change the grouping of adding here. Alright, so that is the associative property. Those are all the properties of addition. All the different properties of addition. Next we have the multiplication properties now. Okay, if 0 was the identity addition, what's the identity for multiplication going to be? 1. Because anytime I multiply by 1, I always get the same number. Why is it not 0?
Because that would mean it would equal 0.
That'd be always 0. That's actually its own property. It's called the 0 property. Okay, but multiplicative identity, 1 is the identity number. So negative 12 times 1 is negative 12. 3 times 1 is 3. And you keep so forth and so forth. Multiplicative inverse. We're going to focus a lot on this. Or not a lot, but we're going to do a lot of this today. Multiplicative inverse. Okay, inverse is the reciprocal. Okay, if you've had me before, some few have. What's another way that I say reciprocal? Who remembers? You call it the reciprocal, because all you're going to do is flip it. Okay, so if you look here, negative 2/3, if you flip it, you get negative 3/2. So reciprocal is also known as the refliprocal. Why? Because we are flipping the fraction around. Okay. Closure property, same thing here. 2 real numbers is going to get a real number. Okay, so closure property is real numbers. Commutative property, same idea. Commutative property, the order does not change the product. So commutative property, I can flip it around. 2 times 1 is the same thing as 1 times 2, and so forth. Okay, flip it around with respect to multiplication. Associative property, same thing. I can change around the grouping. It's going to be the same. The only difference is I multiply here. 3 times 7 times 4 is the same thing as 7 times 4 times 3. Change around the grouping. Okay, and then the new one here, distributive property. What is key when you distribute? What is something that a lot of students forget about distributing? What's popular, Drew? They forget the negative. What else is common? What do they always forget to distribute to? The first or second term, probably. Yeah. A lot of times they forget to distribute to that second term. They forget that negative. So distributive property is taking it to both terms. All right. So that's the properties of multiplication. You will see those again on a quiz or test in matching form. First thing we're talking about here is number 1, finding the opposites and inverse. You will see number 1 again. Let you know right now. You'll see that. Quiz, test, you'll see that one again. Negative 3.2. Everybody does a great job with the opposites. Okay? If it's negative 3.2, the opposite of that is going to be a positive 3.2. Everybody does that one pretty well. It's this one. It's this inverse one that causes students troubles. Now let's think about it here. What was another way to say inverse, I said? We called it the reciprocal, or also known as the refliprical, right?
So it means
That's decimal. So a lot of times, here's what students do. And this is the common mistake. They go, okay, yeah, I can write this as a fraction, right? Because reciprocal means fraction. So I'm just going to say, okay, 1 over negative 3.2, right? That's a fraction.
It'd be 3.2.
Well, technically I had to go 3.2 over 1 here first and then reciprocate it. But here's the problem. What's wrong with this? What is wrong with this right here? Two things. Negative can't be in the bottom. And also, can I have a decimal in a fraction?
No.
I cannot have a decimal in a fraction. That's wrong. So, okay, back to the drawing board here. Let's think about this. What placeholder is that right there? That is called the tenths. Does anybody know why it's called the tenths? Because if I were to write it as a fraction, I write it over 10. Negative 3.2 is nothing more than negative 32 over 10. Okay, to write that as a fraction, I would write that over 10. Now I have it as a fraction. Now there's no decimal. Now can I do the reciprocal? Yeah, now I flip it around, getting me negative 10 over 32, which simplifies to negative 5 over 16.
So why can't you just do like... Oh, okay.
See now? Again, you will see this one again.
So you can't put it over 1 though?
No, because you can't have a decimal within a fraction. That's where it goes wrong. Okay? And that's where a lot of students, when you see this on tests, a lot of students will want to do that. Put it over 1 or flip it over that way. But you got to put it as a fraction first.
Just multiply it in the decimal times 10.
Yeah, just think of your placeholder and just write over 10. We'll look at a couple more here in a bit. 2, 3/5. What's the opposite of positive 3/5? Jace, what's the opposite of that? Negative 3/5. This one's already a fraction. Great. How do I do the inverse of this one, Drew? Flip it and I get 5/3. Awesome. If it's already a fraction, those are kind of the easier ones. It's the ones that are decimals, we have to change to fractions that make it tougher. Take a couple seconds, try numbers 3 and 4 on your own. Notice, on number 4, it's not the 10th spot here. Recognize that. All right, let's look at this here. Number 3. What is the opposite of negative 9/4? Mr. King. Positive 9/4. What's the inverse of that? No. It would be negative 4 over 9, yep. Because I just flipped the fraction around. Yep, inverse is just flipping the fraction. Okay? And again, recognize, remember, always want to associate the negative either in front or the numerator, never the denominator. All right, 4 opposite. We should be able to get the opposite. Hannah, what's the opposite of positive 3.25? Hannah, what's the opposite of that? So if it's positive, what's the opposite of positive? So I would say negative 3.25. Mr. Crump, you think you got the inverse?
Yeah, let's go for the opposite.
It's something negative 100, isn't it?
Okay. Let's think about this here. Let's look at the placeholder. Katie, you think you got it? What do you got? It is 4 over 13, actually. Nice job. Okay. Let's look at this here. I have 3.25. What placeholder is that in?
Hundreds.
Hundredths. Why is it called the hundredths? Because to write it as a fraction, I write it over hundreds. I would say 325 over 100. Now I do the inverse. I would flip it. So I have 100 over 325. Simplify that, and I get 4/13. Again, that's why we have these placeholder names. Okay, that's why back in elementary school they're like, yeah, learn these placeholders, tenths, hundredths, thousands, so forth and so forth. Why? Because when you got here, when you write them as fractions, you know what their name was. It makes it easier. Yes, sir.
Like after something, like would we have to show you that we're flipping it, or do we just skip to the flip part?
You can probably just skip to the flip part. Okay, good work there. Does the decimals make sense for everybody? How we get there?
Don't we have tests?
Don't have time. Next thing we're going to do is identify some properties. So now we're looking at those properties from earlier. Okay, I want to identify properties. So 5, I have 6x plus 3 plus negative 2x equals 6x plus negative 2x plus 3. So what property says I can switch around the way in which I add and still get the same answer? Which property might this be? Chow, what are you thinking? Okay, now there is close. It's not commutative. It's one just like commutative, but it's more numbers. Which one is very similar to commutative? Allie? What was it? That is the associative. What is the main difference between associative and commutative? No. It's a group. So this is the associative property of addition. Associative means a lot of times that you will have the groupings. Okay? Associative means you'll have those groupings at times. That is the associative property.
Wouldn't it be 9x plus negative 2x?
No, because you can't combine 6x plus 3.
So you would just take 6 plus negative 2, which would make
4x plus 3 is they both end up with.
That's what I heard.
Yep.
Wait, so when you ask like for identifying properties,
I just want the name of the property. So you don't have to do the work. Because it's a property, both sides are already be the same anyways.
can we just like do the work?
Huh?
Can we just do the work?
No.
Done.
6. We're going to pick out this property. What property says I can flip them around and get the same answer? Allie? That is the commutative property of what? Yep. Commutative property of multiplication. Okay. Commutative means I flip them around. Yes, ma'am.
When we're all done, can we go back to the slides and jot down the
Yeah.
properties?
You bet. 7. 7's kind of a tricky one here. Okay? 7's a tricky one. A lot of times people want to do with their gut instinct. Their gut instinct's wrong here. Okay? Anybody think they have an idea what property this might be? Again, look at the groupings. How are we rearranging it? A lot of people want to say distributive right away. Why do they say distributive? Because they see the 3 and the 4, right? That's what they always see. It's actually associative. Okay, this is actually associative property of what, Drew? Yeah. It's associative property of multiplication. Why? Why? Because I'm changing the order of the grouping. Instead of 4 times pi, I'm doing 3 times 4 first. I'm changing around the way I multiply. Distributive property typically always has multiplication and addition in it. Distributive property is the one property that has both addition and multiplication at the same time. Okay? Associative property changes the groupings. Commutative just flips it around. Take a couple seconds and try these 3 on your own. Okay? Identify these properties. Take a couple seconds to try these 3 on your own. All right, number 8. Mr. McCoolidge. What do you think you got? That one is not associative. This one is actually this is the distributive. This is the one I was talking about. Okay? This is the one that typically has both multiplication and addition or subtraction in it. Why? Because I'm distributing that to both of them. So this is the distributive property. What about 9? 9's tough. Jake O'Connor, what do you got? Multiplicative what? That is correct. That is the multiplicative inverse. How do you know that? Okay, because it equals 1, or also because they are what? They are reciprocals. When you see the reciprocals there, that means multiplicative inverse. And 10. 5 plus 0 equals 5. What would 5 plus 0 equals 5 be, Allie? That is the identity property of multiplication or addition? Addition. Yep, that's the identity property of addition right there.
It always equals like the same.
Yep, identity always going to come out to equal the same. Yep, key there is identity is always the same. Inverse properties will always be reciprocals or opposites. Associative property would have groupings on both. Okay, so associative ones would have parentheses on left and parentheses on the right still. Okay, commutative is just flipped. Those are kind of the parallels.
What is commutative?
Commutative is just flipped. So commutative property would be like 1 plus 2 equals 2 plus 1. They're just flipped around. It's just two things flipped around. Associative property would always be like 3 or more things. But commutative is just 2 things flipped around. All right, last thing we're talking about today is doing some mental math. About every percent you can do can all come from 10%. We can estimate almost any percent based off the 10% rule. For instance here, I want to find 10% of 78. We talked about earlier, it was in our warm-up. How do you do 10%? So you move the... So 10% of 78 is 7.8. Everybody does 10% pretty well. It's now using the 10% to get to the different percents. For instance, I want to get to 5%. How can I use the 10% rule to get to 5%? I don't want to move it twice. If I move it twice, I'm getting to 1% actually. I would want to move the decimal place once and then do what? Yeah, think about it. How do I get from 10 to 5? I take 10% divided by 2, right? Does everybody agree 10% divided by 2 is 5%? Okay. Well, let's find 10% of 36. What's 10% of 36? Well, that's 3.6. 3.6 divided by 2 gets me. And that is now 5% of 36. That's 1.8. Okay, again, I can use that 10% rule almost any time and get to any percent out there. Next one, 15%. It's almost like a tip. Ooh, real life math. 15% of 50. Well, how do I get to 15% using 10% still? What did you say, sir? Yeah. So does everybody agree I can do 10% plus 10% divided by 2? What's 10%, right? Well, that's 10. 10% divided by 2 is 5%. Does everybody agree 10 plus 5 is 15? So, okay, let's do this here. So what's 10% of 50? It's 5. So take 5 plus 5 divided by 2. So 5 plus 2.5 gets me 7.5. Again, we can get to almost any percentage using the 10% rules. Take a couple seconds and try these two on your own. Using the same 10% rules, find 5% of 4240 and 30% of 25. Take a couple seconds to try those two on your own. 5% of 4240. How do I get to 5% again, Beast? How do I get there? And then divided by? So 10%. So that's 4.24. Divide that by 2, and I got what? $2.12. 15. Well, how do I get to 30%, Miss Foster? What? Foster.
Get your mind off of the gun.
Allie, how'd you get 30%?
I don't know. I didn't know.
King?
I tried.
How do we get to 30%, guys? From using 10%. Crump.
You move it over to get 2.5 and multiply it that way 3.
Perfect. Yeah. How do you get to 30%? You take 10% times 3. So I'd find 10% of 25, so that's 2.5 times 3. And I get 7.5. Somebody earlier today was like, well, I just did 10% plus 10% plus 10%. Does that work?
Yeah.
Yeah, that's still 30%. That's not as quick, but that's still 30%, right? Again, you can get to almost any percentage using the 10% rule. All you have to be able to do is multiply or divide, and you can get there. Here's your assignment.
What?